Hey folks, how's it going? So what we're going to do today is we're going to try to apply our integration skill to something new, whereas we're going to get something called the definite integral, which you're going to see today. All right. So the definite integral. So to introduce this, what I'd like to do is I'd like to do a problem first. So if v of t, so the velocity of some object is 2t plus sine pi t, I want to determine the total displacement of a traveling object. Okay, so displacement means if an object, for example, starts over here and ends over here, now it could travel like that, right? The total displacement is this straight line. All right, so the displacement's always going to be figured out as the end. So the ending point subtract the starting point, right? So if it started 2 meters away and it ended up 5 meters away, its total displacement is 3 meters. It doesn't matter which way it went, it's always from 2 meters to 3 meters, 2 meters to 5 meters. All right, so let's do all that. Okay, so what I want to do is I want to find the ending point and I want to subtract the starting point. Okay, so let's see the ending point, right? So remember, all we're going to do is we're going to do the integral of v of t, okay, dt, and the integral is, so here let's write it out, so the integral of 2t plus sine pi t dt, okay, so that's the integral of 2t is just t squared, right? 2t squared over 2, 2's cancel out. The integral of sine pi t, you guys should recognize from yesterday, is negative cos pi t over pi. And then we add a constant, okay? So now what we have to do is we have to plug in 2. Okay, so this is now the position equation, right? So remember, the integral of the velocity is the position, just like the derivative of the position is the velocity. So let's figure out the position after 2 seconds. Okay, well, it's 4 minus cos 2 pi over pi plus a constant. So this is 4 minus cos 2 pi is 1 plus a constant. Okay, now how about the position at the start? So now I want to figure out the position at 0 seconds. So this is going to be 0, right? 0 squared minus cos 0 over pi plus a constant, right? So this is just 0 minus 1 over pi plus c. Okay, and now what we want to do is we want to subtract p at 2 minus p at 0. Okay, so the displacement is going to be p of 2 minus p of 0. And what that is, so I'll just sub everything in. So p of 2 minus p of 0. And now let's see what happens. Well, minus pi minus negative pi, so plus pi, cancels out. Plus c minus c, so these constants actually go away. And all we end up with is 4. Right? So the total displacement of this object following that function, doesn't matter which way it traveled, the total displacement that it underwent is 4 meters. Okay? So notice that all we did was calculate p at 2 minus p at 0. Okay? So p at 2 minus p at 0. And in other words, what we did was we did the integral of the velocity at t equals 2 minus the integral of the velocity at t equals 0. So another way to write this, a little bit more compact, is the integral from 0 to 2 of the velocity. Okay? And this is called the definite integral from 0 to 2. Note that when we compute a definite integral, we get a numerical answer, whereas before we would get a function as our answer. Okay? Alright, so let's put this into practice, and I'll show you some notation that we use along the way. Alright? So I want to determine this integral here. Okay? So what that means is that we want to take the integral, so let's take the integral. Remember, this is 3 times 1 over x plus 1, so the integral is going to be 3 times ln absolute x plus 1. Okay, now after we've taken the integral, this sign isn't there anymore, so we need somewhere to put our bounds. And the way that we do that is we put a little line at the end, and we say from -2 to 3. So this line, you read it as evaluated at, so it's this function evaluated at -2 to 3, so lower bound, upper bound. Okay, so now let's actually do that, and what we get is 3 ln 3 plus 1 minus 3 ln -2 plus 1. Okay, so notice that now I'm not even putting c's in anymore because I'll have plus c here, plus c here, and they'll cancel out. Okay, and here I didn't even put an absolute value because this number is positive, right? So it doesn't need to be there. So here we get 3 ln 4 minus 3 ln -2 plus 1 is -1. Take the absolute value as +1. Well, 3 ln 1, you got to remember that the value of that is 0 because the question is e to some exponent is equal to 1, so we know that is exponent 0, so ln 1 is 0. So our answer is 3 ln 4. Okay? So that integral boils down to 3 ln 4. Okay? Okay, let's try one more. Here, we want to get the integral of x e to the x. Well, the problem is, what we have is one function times another function. Okay? So we're multiplying two functions together, which means that we would need some kind of integral of a product rule. We don't have that. Okay? So what we have to do is we have to figure out a better way to do it. Okay? And for now, we're kind of stuck. So what you guys have to do is use your graphing calculator. Okay? So two ways to do it. One way is actually enter this into your calculator when you go menu, calculus, and then integral. Okay? So that's one way. And then it'll give you the sign, so all you got to do is enter the lower bound, upper bound function, and the dx. Okay? The other way to go is to literally type into your calculator NINT, so you can do this along with me, so this means numerical integral, open a bracket, type in your function, okay, so I would always put a bracket around my function, comma, lower bound, comma, upper bound, comma, and then explain to the calculator that your independent variable is x. So function, lower, upper, independent variable, okay? And when you press enter, you should get your answer. Okay? So do that, bring it to class tomorrow, and I will see you with your homework, which will be this if you want to get started. Alright, see ya.